All right, so this problem involves the relationship between the area and perimeter of a rectangle. And it gave you this really cool, nifty tool in your book. If you were just looking at it in a textbook, you lost the ability to drag and move things around. I'm going to show you that today. So Sophie is claiming that whenever she increases the perimeter of a rectangle, all right, so whenever she increases the perimeter of a rectangle, its area increases. So anytime they increase the area, increase the perimeter of a rectangle, its area increases. So if I am, and I can't click this here, so that's her claim. So I don't know if it's true or not right now. We're gonna mess around with this. We're gonna mess around with this guy here and move these around and see what's happening. See what's happening to the perimeter and the area, right? Can I make one bigger without the other one, right? So if I'm doing that, the area and perimeter are increasing. Is there a way to move it around so one increases and one doesn't, for instance? That's what we're gonna test. So here we go. Where was I? Oh yeah, losing my mind, folks. So Sophie showed the rectangle at right and said, if I make the base twice as long, then the area increases. If I make this twice as long, right, then the area is going to increase. Is her statement correct for the figure? Draw a diagram and explain whether the area is greater or less than the rectangle at the right. It's bigger. We're going to have more squares that fit in here. If anybody is not sure, let's do it. So this, we're looking here at the length is at 6 units currently. And let's move it to 12 and see what's happening to the area. So the area was 18. If I double the length, I actually doubled the area. I just made it twice as long. Here was the original rectangle. Here was the original rectangle. And I added a whole nother one right on top. So I doubled it. If I doubled the length, I doubled the area. And then B, is her claim about the relationship of area and perimeter correct for all figures? For example, is there any way that she could have a rectangle with a greater perimeter than the figure in part A, but have the same area? So can she have a greater perimeter, but with the same area? So let's figure this out. All right, so here we go. Here's our original rectangle back, and we're trying to see if we can keep the same area, so the area of 18 square units, but yet make the perimeter larger. So if I play around with this, and if I actually make this guy a nice long skinny guy here, the perimeter is still quite large. The perimeter is at 14 and the area decreased drastically. Let's move this out now, and you're going to start to see that as we're getting the area closer back up to 18, that this guy goes way up, way past 18 here. So if we can drag this guy, can move that guy, but not this guy. There we go. So if I'm moving it out, it's already at 18. It's already at 18 units. 18 units for the perimeter. So that's already the perimeter where it was for our other shape, our 3x6 shape. And the area is only 8. So if I take it even further out, as I approach the same area of 18 square units, the perimeter is already at 30 units. So here is 18. This shape has the same area of the shape that we explored before, and the perimeter is 38 units. So yes, it is possible to increase the perimeter without increasing the area. All right, see you later.